All right, we're back. We're still on page 6 of notes 15. We're taking limits of Riemann sums to find the exact value of definite integrals. And I'm just going to jump in and do this one. It's the only one I'm going to do in the video, so start off wrong. Delta x is, you're going from 1 to 5, so 5 minus 1 over n, so 4 over n. And then x sub I is where you start, plus I times delta x, so 4i over n. And then f of x is just this. All right, let's go. So it's going to be the sum from 1 to n. So this gives us an approximation of the area. So it's the area approximation as a function of n. And it's going to be f of x sub I. So 3 x sub I is 1 plus 4i over n squared plus 2. And then delta x, which is 4 over n. You can always factor that delta x out. So like, I mean, some of you probably start by doing that. So this is going to be, I'm going to take this 4 over n out, which is that's the delta x I was referring to. So this guy is already out here. And then I'm going to expand. And in the next step, I'll probably simplify. So it's, all right. So I'm going to like multiply by 3 as I do it. Hopefully you do that correctly. So when I'm squaring this, it's first thing squared is 1, but then times 3. And then multiply these together, you get 4i over n, times 2 is 8i over n, times 3 is plus 24i over n. And square this, 16i squared over n squared times 3 is 48i squared over n squared. And then plus 2. Okay, so one more step, I think, and then we'll use formulas. And so we get, why would you autocorrect that? And, all right, here we go. 5 plus, there's like nothing to simplify. I over n plus 48i squared over n squared. So you just gotta have like confidence when you're doing these. All right, so I'm gonna pull out the 5 and I'll get 4 times 5 over n, so 20 over n. And then the sum of 1 is just n. Plus I'm pulling out 24 over n. So 4 times 24 is 96 over n times n is n squared. The sum of I is n plus 1 over 2. And then I'm gonna pull out 48. 48 times 4 is 196. 192, right? Yeah, 192. And then over n cubed. And then sum of I squared is n plus 1, 2n plus 1 over 6. Whew. Okay, so that's our approximation as a function of n. Now what we want to do is the true value. So the integral from 1 to 5, some bird just made a noise that scared the crap out of me. 1 to 5, 3x squared plus 2. The integral from 1 to 5 of 3. I was going to go back and like highlight stuff, but I think I combined too many things for it to like really be meaningful at this point. Kind of. I mean, like you can do a little highlighting. You like this became this. And maybe if you highlight enough, you can see like where the other things came from, potentially. This. Okay, it's the limit as n approaches infinity of this stuff. Copy and paste, definitely. Nobody wants to handwrite that again. I remember when I was in high school taking this, I hated writing all of these. And I felt like a true genius when I realized like most of the things in here like just don't matter, and most of the things in here don't matter. Like that felt so good when I like finally made sense of that in my head. It's like, oh, we're going to infinity, so only the dominant terms matter. 20 plus 96 over 2 is 48 plus 192 over 6. Blah. Well, where did 192 is 4 times 48, and 48 divided by 6 is 8. So I think that's 4 times 8. I think it's just 32, which would make this really nice. Is this just straight up 100? 50 and 50? That's suspicious. Let's go to the calculator. I mean, like, if it is, that's fine, no problem. See, my mic like has stopped telling me that it's on, and it's so annoying. I'm gonna mute and then unmute. Ready? You'll never even know. Okay, I muted and unmuted, and now the mic symbol is working again. The peace of mind that provides is like out of this world. I'm just gonna do the definite integral, because if it matches up, then it's right. 3x squared plus, and if it doesn't, back to the drawing board. 132, what? I don't know. Oh, I got myself. I know what I did wrong. Okay, hold on. Let's go back. Classic mistake. So it's almost good, right? Almost. It's never great to make mistakes, but classic. Okay, the mistake I made is right here. So how do I like highlight that in like terrible? Right here. I forgot it. I forgot this. Don't forget that. I did. So I did 192 divided by 6. I shouldn't have. I should have done 192 divided by 3. Do not forget. Classic mistake. So this isn't 32. This is 64, which makes this 132. So it's good. It's really good that we checked that one. Man, that's so annoying. That's it. That's the #1 mistake people make when they're taking that limit. I've probably said that before in videos, and then I did it. Crud. All right. Well, anyway, I guess it didn't go that poorly because at the end we had it, but stop this video here, come back in the next one, and do some more. So I will see you there.